Good morning, ladies and gentlemen. I welcome you to the second day of the 11th Griha Summit. I request everyone to please be seated as we're about to begin the session. We're expecting more people to trickle in as we go. We'll begin the session meanwhile. I would first like to make a safety announcement. TERI is a Quality, Health, Safety and Environment Certified organization. In case of any untoward incident like fire, evacuation is required. You are required to exit from this auditorium through the fire exit gate nearest to you without any panic. There are 7 exit gates from this auditorium, 4 on the ground floor, right, left and 2 main entrances. There is 1 exit on the stage and 2 exits on the balcony. In the case of a fire, fire marshals will take their position in the aisle and exit gates to help you evacuate. Thank you. As you may all know, that Griha Council every year goes a step beyond conventional exhibitions. And for instance, we had Sparsh during the 8th Griha Summit, Praroop during the 9th Griha Summit, Akar during the 10th Griha Summit. This year we have Venu Kutir, a 240 square foot bamboo cottage inspired by the form of a bird's nest. It has been designed to create a comfortable living space using only bamboo as the predominant building material. Do visit the exhibit.
Can buildings of the future be different? Welcome to Venu Kutir. Set up in the India Habitat Center, a comfortable living space put up in 8 days. With prefabrication work of 8 days, this cottage shows the potential of what could be the most sustainable and stunning building material of tomorrow: bamboo.
Bamboo is hollow from within, but otherwise a strong material. Its tensile strength can match that of steel, and its specific strength matches that of concrete. Construction involves a lot of concrete and steel, and producing these two elements releases a lot of GHG emissions. On the contrary, bamboo sequesters carbon and is environmentally friendly. It's one of the most easily and cheapest structural material that can be made available for construction purposes. Clearly, from the climate goal perspectives, bamboo is a material that should be promoted.
Bamboo structures require a separate method of design as compared to steel and concrete. And here is how this one works.
So this is a bamboo structure where the entire structure is used from staple bamboo. The framework is made from bamboo on which the roofing is fixed. The roofing is made from bamboo shingles, which is pasted on wood polymer composite, typically called as WPC, which is also a green material. The walls are made from flattened bamboo on the exterior face, as you can see here, and the inner face is made from bamboo mat, and both are fixed on WPC sheets on the bamboo framework. So the entire column, beams, the purlins, the entire load transfer happens through bamboo. The flooring is strand woven flooring. It's also a bamboo material completely. The fixation is designed and done using bamboo pegs, because if you put nails, the bamboo will split open as the fibers are vertical. So that's what the entire structure is all about.
Be it a cold place, a hot region, or a high wind area, bamboo is suitable for all climatic conditions.
What we are trying to demonstrate here through this bamboo structure is that a good quality, structurally sound, aesthetically beautiful bamboo structure can be built, where the lines, levels, a good modern looking structure is possible which is what is suitable for the urban population. That is what they look at, a good contemporary design structure.
Countries like Indonesia, Vietnam are leading in bamboo architecture, and so could India.
There is every reason to believe why bamboo will become one of the most important building material in a country like India. But we need concerted efforts in this direction.
Reducing costs of construction to come at par with steel and concrete buildings and developing a large base of skilled manpower will help in wider acceptance of bamboo among builders and architects and position it as an affordable housing solution.
The Venu Kutir certainly sets a precedent for housing in India in the future. I'm Gauri Mathur, and on behalf of the Griha Council and the UNSW Sydney, I would like to extend a very warm welcome to all of you for the plenary session on Water Challenge. About 3/4 of the households in India do not have access to drinking water. With nearly 70% of the water being contaminated, India is placed at the 120th position amongst 122 countries in the Water Quality Index. With this crisis, With this crisis expected to worsen in the coming years, this session aims to seek integrated solutions to the impending water crisis and would discuss the technology, infrastructure, and investments required to provide safe and accessible water, implications of the water crisis on health, food security, and economic growth, and appropriate design of urban spaces for efficient use of water resources. On that note, I would now like to invite all our esteemed speakers and the moderator of the session to the dais. Professor Greg Leslie, Director, Global Water Institute, UNSW. Mr. Amar Tendulkar, Head Design, Mahindra Lifespace Developers Limited. Mr. Dan Alluf, Counsellor, MASHAV Agriculture. Dr. Syamal Sarkar, Distinguished Fellow and Senior Director, TERI. Mr. Divyang Waghela, Head Tata Water Mission, Tata Trust. And finally, Dr. Sherly, Assistant Professor, Department of Regional Water Studies, TERI School of Advanced Studies. Let's extend a warm welcome to all our speakers with another round of applause. I would request our esteemed speakers to please come together for a group photograph before we begin the session. Thank you, sirs. I now take the pleasure of introducing the moderator of this session, Professor Greg Leslie. Professor Greg is the Director of the Global Water Institute and the UNESCO Centre for Membrane Science and Technology at the UNSW Sydney. Prior to joining UNSW, he worked in the public and private sector on water treatment, reuse, and desalination projects in Australia, New Zealand, Singapore, Hong Kong, and the United States. His experience includes work on the NE water recycling projects for the Singapore Public Utilities Board and the groundwater replenishment system at the Orange County Water District in California. It's an honor to have you with us, sir. I would now request Professor Leslie to kindly introduce the esteemed speakers. Sure.
So I stand here or just do it from there?
So, however you're comfortable.
Is it on?
That's fine. Is it all right?
It's perfect. Okay. I might just do it there. Is that all right?
Sorry?
Do you mind if I just do it for you?
Sure, sir.
Perfect. Ladies and gentlemen, thank you very much. It is indeed an honour to be here today. I'm very grateful to Griha for the opportunity to participate in this forum. I stand before you very concerned, yet very hopeful. In Australia at the moment, I think a number of our speakers have spoken about the similarities between Australia and India in terms of water needs. Obviously the scale is very different, but we're in the middle of another drought that has come less than 5 years on the back end of what was referred to as the Millennium Drought, in which our cities invested tremendous amounts of money in recycling and desalination to secure urban water supplies, while our government implemented the final stages of a 30-year journey to reform water distribution in rural areas and the allocation of our rivers, which are vulnerable to a variable climate. And so notwithstanding that, we find ourselves again in a crisis in Australia. And there are similar stories in other parts of the world, including India. Yet I am incredibly hopeful. I have the really good fortune to work with a number of Indian organisations, have had the opportunity to work with a number of good Indian organisations. The Tata Trust is one, but TERI, the IITs at Ropar, we had the students here yesterday, and Roorkee, of course TERI, and IIT Delhi. And the appetite for change, the appetite to rethink business as usual on how we manage water in India is very strong. And it reflects trends in other parts of the world, including Israel, Europe, Australia and the United States. So there is action. Water is one of the markers, one of the sentinels of a variable climate. We know that the climate will become warmer and drier in certain parts of the world, while our rainfall events will become more intense. So we're juggling water scarcity with more increased flooding. And so we really need to rethink everything, from the way food is produced, to the way floods are managed, to the way power is generated, to the way water is used in an urban context. And it's inherently multidisciplinary. And Professor Jacobs, our Vice-Chancellor, stood before you yesterday, and I'm sure he probably thinks he has the best job at UNSW, whereas I know I have the best job at UNSW, because I get to run an institute that covers 7 faculties with nearly 300 academics and researchers that are all interested in different aspects of water. From lawyers, public health, human geographers, people from the arts and social science, the built environment, some of whom are here this week, engineering and science. And our institute is built around 3 pillars that are aligned with 3, I think, of the big challenges that our speakers are going to talk about today. It's the whole issue of water governance and security. How do we manage water to secure our future? And we define security as security for the environment, security for food production, and security for our urban centres. How do we govern it? And it's connected water, it's surface water and groundwater. The second pillar is what we refer to as healthy oceans, resilient coastlines. Our rivers are connected to the oceans, and one of our speakers today works on marine plastics. Big problem. 90% of the plastics that are entering our marine ecosystems originate in 7 rivers. So the connection between rivers and oceans is really strong, and then the effect of climate change, particularly more intense and frequent storms and storm surges in the coastal regions, the effect they have on the intrusion of groundwater, seawater into our groundwater is really important. In fact, Divyang and I were in Gujarat a few years ago, where the variations in the monsoon is meaning that seawater is getting drawn in further inland as the groundwater gets pumped down. There's things that we've got to deal with in a connected way. And then finally, how do we reach the most vulnerable? Our third pillar is water security, access and equity for all. How do we get to that last mile? How do we secure water not only in our cities, but in the areas where people don't have access to the same infrastructure? It underpins Sustainable Development Goal number 6, safe access to water and sanitation. And then protection of our water ecosystems underpins several more of the sustainability goals. So water needs to get, we need to get that right. But I'm very hopeful. I'm very hopeful that people are now changing business as usual. They're looking at water in a different way, and that's what I'm delighted that our speakers are going to address today. So our first speaker is going to be Dr. Kumar. Sorry, let me just get your introduction up, Dr. Sarkar, apologies. Syamal Kumar Sarkar is the Distinguished Fellow and Senior Director here at TERI, where he heads the Natural Resources and Climate Program. He has a doctorate in economics. Again, we need to value water, we need to understand the value, and economists are very important. He's had a distinguished career in the Indian government, mainly in the Ministry of Water Resources and in the Water Pollution Control Board in West Bengal. He's well published and has a wealth of experience in both academic and government circles. He's going to be talking to us today about the importance of the Sustainability Goal 6 in the Indian context. And would you join me in welcoming Dr. Sarkar.
Thank you, Professor Craig, for the nice introduction. And in this first session of this plenary, I will be talking about the Sustainable Development Goals, particularly in the water sector, goal number 6, which many of you are aware. Goal number 6 talks about sustainable management of water and sanitation for all. Before I deal with this subject in details, I will be talking 3 aspects of sustainable development goals, especially goal number 6, the access. Then I will be talking about the quality of water, and third, the water use efficiency. So on these 3 areas I will be dealing while I will be deliberating on the SDG 6. Just to give a by way of background, we know that water is essential for life, livelihood and ecology. It is critical for food security, energy security, national security as well as economic development. In India, the estimated annual precipitation including snowfall is about 4,000 billion cubic meter, and the estimated utilizable water is only 1123 billion cubic meter. Out of this, the surface water constitutes about 690 billion cubic meter, and the remaining constitute the groundwater. Water demand is growing in full swing in Indian context as well. It is true for all over the world. And in India, irrigation is the most contributing to its demand. By 2050, it is expected to increase the demand to 1180 billion cubic meter, and it is expected to surpass the available water supply by that time. if we do not change our behavior and the management process. The climate change is also impacting, will be impacting the water availability in India as well. The per capita water availability is decreasing over a period of time, and it is going to touch the water scarce situation in the near future. The groundwater is extensively used for the irrigation and the drinking purposes. The recharge of aquifers is many cases less than the extraction of water in some states. For example, in Delhi, Haryana and Punjab, the extraction is much more than the recharge of aquifer. The groundwater is yet to be considered as a common pool of resources, so extraction is arbitrary and haphazard. There is a need for complete scientific mapping of the aquifers, and there is a need to change the legal framework, the change of mindset, in addition to the involvement of the main stakeholders in water deliberation process. Given this overall scenario of water, what are the challenges of meeting the sustainable development goals? All of you are aware that by 2030, India is committed to fulfill the goals, fulfill the mandates given under the goals of sustainable development. So let's take the goal number 6.1. Goal number 6.1 says that by 2030, India needs to achieve universal and equitable access to safe and affordable drinking water for all. If the goal is given, what are the actual situation in our context? There are many citizens in our country which are without safe water as on today. The December 2019 figure says that about 81% of the rural habitation having 76% population have provision of minimum 40 liter per capita per day of potable drinking water. So we are still talking about 40 liter per capita per day. We are now talking about 55 liters, which is called the functionally household tap connection. You know, this Government of India's recent announcement that by 2024 the functionally tapped water connection should be given to all households. Now what are the situation now? There is a big gap. There is a huge gap of rural household without tap water connection. For example, in UP, 25.5 million people, they are without any connection of water, piped water connection. Bihar, it is 17.5, West Bengal 16.1 million, MP 9.5 million, etc., etc. So there are many states where the access of water, particularly the piped water connection, does not exist. So the question is that how by 2024 we can meet this target set by the Government of India. What should be the community participation in this case? What should be the contribution of the rural people or the urban people in this exercise? What should be the role of the village officers, the CBOs, the NGOs in planning, designing and implementing this program of the Government of India? What should be the role of the corporate? The role of the corporate will be a big challenge because we will be targeting the rural people in a big way. And as you know that the mindset of the water managers in implementing this project is also very important and also a critical point of this journey. Now SDG 3. SDG 6.3 is talking about the fact that by 2030 India has to improve the water quality by reducing pollution, halving the proportion of untreated wastewater and subsequently increasing recycling and safe reuse globally. In India, about 3 lakhs rural habitation are having water with a lot of problem, contamination, water quality issue. And as you know, there is a huge disease burden due to poor water quality. In India, about 2 lakhs annual deaths occur from inadequate sanitation, water and hygiene. In urban areas, 1/3 of the water are not treated. So the untreated water which goes to the sewer are creating problem from the point of view of the water quality. Now goal number 6.4 is talking about the water use efficiency in all sectors. That by 2030 we have to improve the water use efficiency in all sectors and ensure sustainable withdrawals and supply of fresh water to address water scarcity and substantially reduce the number of people suffering from water scarcity. In India, our water use efficiency is very unsatisfactory. The irrigation sector, which consumes most of the water, about 80% water demand are created in the irrigation sector, and there the water use efficiency is only barely more than 30%, is approximately 38%. So if that is the situation, we can imagine that how much water we are not saving the water is going waste actually. In domestic sector also there is a lot of leakage, more than 50% water is leaked in the domestic sector in many cities. Similarly also in the industrial sector we have this problem. We have a national water mission which was created after this climate change as a step to combat the climate change. They have set a target to achieve 20% water use efficiency in all sectors. So, but there are no fixation of the program sectorally, and that is a big challenge before the government. Take the case of the micro irrigation, which is as a step for improving the water use efficiency. In India, the target of micro irrigation water use efficient area is 70 million hectare. We have achieved only 9 million hectare today, and our per annual rate of meeting the target of micro irrigation coverage is 0.6 million hectare. So it is very, very poor, actually is not very satisfactory. There is a need to effective implementation of micro irrigation schemes, because it is the funding is done by the central government, the state government and also the consumer. And on the implementation, there are a lot of implementation issues. There is a need to build the capacity of farmers and the other stakeholders. There is a need to give the infrastructure status to micro irrigation sector, because that will reduce the operation cost and also allow this sector to have the single window clearance. Underlying these three Sustainable Development Goal 6 which I have discussed on three aspects, India faces the generic water challenges. The first one is the governance challenge. In India, like in many other countries, water is a state subject. So constitutionally, the central machinery, the central government has little role except in managing the river regulation. The management of the water rests with the state government. So unless the state government objective and the central government objectives are in unison, it is very difficult to to achieve the target of various missions in Indian context. There is a need to build the capacity of various stakeholders. There is a need to change the mindset of the water managers, because the water managers in our context, in our particularly those who are working in the governmental sector, they are adapted with the engineering aspects of the whole subject. The management issue of the water is less talk about among that community. So there is a need to have change of mindset, because all our formulations are based on the 20th century setup. We are in the 21st century. So the 21st century's water challenges has to be resolved through the steps where we need to change the mindset of the water manager as well. So thank you very much for this talk. Thank you very much.
So there'll be time at the end for questions and discussion. It's now my pleasure to introduce Mr. Dan Alluf from the Israel Embassy here in Delhi. Dan is an agricultural expert, and he's leading a very extensive Israel-India agricultural project that has 16 sites looking at the total value chain of key agricultural products all the way through. Dan has a Masters of Business Administration from the Technion in Israel, and has undergraduate qualifications in plant science, agricultural economy and engineering from the Hebrew University. And would you join me in welcoming Dan?
So, hello, my name is Dan, as you presented. I thought of talking about three topics. First of all, to introduce in short what Israel is doing. The second is to say what we are doing together, India and Israel. And the third is the way forward, is really talk about what we do. As you were presenting, I am a farmer, and it's something that is always an engine within me, because everything we do here, which is on a government-to-government level, I always think about what are the action items. How do we finish a meeting? How do we finish an engagement with India counterparts, in which we know that when we close a notebook, when we finish a presentation, we are continuing to do things that are implemented and are on a ground level counterpart. And this is because I am here leading MASHAV, which is Israel's Agency for International Development Cooperation. So what we are looking into is capacity building, is knowledge transfer, and this is what we are doing actually on the ground. You were mentioning what we are doing in terms of the Indo-Israel agricultural project. I will leave this to the second part of the very short lecture I'm giving, to say what we do in this IIAP. Israel. Israel is a young country, as young as India. We got independence in 1948, and our first national challenge was water scarcity. There is not enough water in Israel. More than half of Israel is desert, which means that actually zero rain all year. When you walk on the natural landscape in Israel, it looks like the moon. There is no canopy, no trees, and this is most of Israel. But saying that, a lot of agriculture was there, and Israel as a state wanted to populate all of Israel, so villages and towns were established. And the first decision taken in Israel in terms of water was that water is a state issue. It is owned by the state for the benefit of the people. And this is a very critical decision that enabled management of water I will touch later on. As part of this, one of the national projects was to take one lake in Israel that has sweet water, fresh water, and bring it to the desert. We call it Hamovil, the transporter, moving water from the north of Israel to the desert south of Israel. And this was done, and it enabled life in the desert. Secondly, water was priced. When you price water, people value water, it was mentioned, and the pricing is something that is ongoing all the time. The pricing is changing, and I will later on explain how today water is priced, because it is quite diverse. And Israel developed. Today it is one of it's a OECD state, very developed in terms of high tech and income. And with it, the level of life came higher, and agriculture is aiming to export most of its product to Europe, requiring a lot of inputs, including water. So the water from the north wasn't sufficient. And if we were relying only on this single lake in Israel, we would have half of the water we needed. So we had to generate water. And generating water came from two main areas. One is recycling urban water. So today Israel is #1 in the world in recycling urban water. About 90% of urban water is recycled. And the second is desalination of seawater and brackish water, but mostly sea. The desalination is drinking water. So today most of the water we drink in Israel comes from the sea, taking away the salts, treating it, and then moving it into the tap in the house. For agriculture, half of the water comes from the cities after it is being recycled, and the other half are still the fresh water. Now, when we are working on such a system, we also implement drip irrigation. So in the 60s, it's already 60 years ago, we invented drip irrigation in Israel, because we had to come up with a system which is not flood and even not sprinklers, because we wanted the most water use efficient system in the world. So drip was invented as a necessity, and with it, like I said, recycled water and desalination, a lot of know-how was developed. So it is really about having the product, drip, but knowing how to design it hydraulically, how to implement it in the right way, and knowing when and how much to irrigate. So all of this came together in Israel to a very mature level that manufacturing is happening and the knowledge transfer is happening. And this is Israel in a nutshell in this regard. So drip irrigation was there. One of the points regarding water, and this is the last point regarding the first part of my lecture, that water is managed by one authority, water authority. It is not, politicians cannot tell the water authority what to do. It is an independent professional body that is managing water both currently and strategically on the way forward, and it enabled a lot of policy-making decisions to take place in a very hands-on manner. So taking the water from all the cities, putting STPs, sewage treatment plants, in the right place, meaning close to the city, but also close to the fields. This was done, and it was done just recently, 15, 20 years ago. And it was done very rapidly because we too got to a place where we didn't have water. And everything was at risk, actually. So there are many similarities, India, Australia, Israel, in this regard. So this is that, and now what do we do together, India and Israel? So we are definitely focusing on water in agriculture. India is the largest market for drip irrigation in the world. A lot of things are yet to be done, but a lot of things are being done. Desalination is happening mostly in Gujarat on the west coast and in Tamil Nadu on the east coast. And I am here leading a flagship project called the Indo-Israel Agricultural Project. It is located in 16 states with today 28 fully active centers of excellence, which are looking on agriculture in a very comprehensive way that takes mango, for example, so doing nursery management to cultivation, but water management, fertigation, canopy management is all inside of that. I just came back last night from one of our centers in Haryana, talking about precision agriculture, because every center out of these 28 are being monitored by satellites, so we can get online data of evapotranspiration, improving the precision of our irrigation. So this is happening, and this is one of the hands-on activities that we are having. A lot of knowledge transfer is being done. Just a couple of weeks ago, we had the largest exhibition for water in Israel, and Jal Shakti minister came to Israel with his delegation and actually exposed himself to the solutions. And now many things are rolling, also before, but definitely also now. And this is the way forward. So in terms of the way forward, I will start with Jal Shakti. A dialogue is happening, so talking about what we can do together, but saying that we really want to implement. So we are looking into identifying areas that are challenged by water in extreme way here in India, and joining hands and working together. It's always demand driven. The Indian partner will always lead the way and guide us what is the scope and scale we want to do together. But within this, how do we make things different? How do we manage water differently? And how do we implement in a way that really changes the lives of the people that are concerned? One of the projects that we're talking about is in Uttar Pradesh, in an area called Bundelkhand. I hope I'm pronouncing it correctly. It is not far, it is close to Jhansi. And there is a very big crisis of water. I imagine most of you know. And we are talking about generating water. So harvesting rainwater, perhaps taking sewage water and treating it and using it, but it is still to be discussed, and using the water that is existing in a more efficient way. So moving the water into the village area, implementing good infrastructure, drip irrigation, and moving even to the agriculture production part with a marketing. So it will all work in a very comprehensive and holistic and sustainable approach. And when we talk about agriculture, our project moves into areas of excellence. So from center to move to area. So every center will take about 75 villages around it, and these villages will become Indo-Israel agricultural level, hopefully uplifting the lives of these farmers in a big way. We are already doing it. Just last year in 2018 alone, we trained 1.4 lakh farmers. So things are happening, but we are looking to do it more. And this is a way forward. So we are really working with India, both on the federal level and state level. So Q&A, I imagine we will take forward the discussion. Thank you.
Thank you, Dan. It's now my pleasure to introduce Mr. Divyang Waghela. Divyang is the head of the Tata Trust Water Mission. One of the initiatives that he looks after is the WASH initiative that's rolling out improved water and sanitation solutions to 5,000 villages across 12 states in India. Divyang previously worked in a number of roles. He was with the Asian Development Bank and has also worked on boards of various water and sanitation organisations. He'll be talking today about two aspects. The first is the need for behavioural change, and the second is about adapting technology for culturally appropriate applications. Would you join me in welcoming Divyang?
Thanks, Greg. It's a really pleasure to be part of this August gathering. I think the first speaker has already spoken about the data part, and I would like to just focus on two core areas, which is more on a last mile connectivity, more on how we actually provide water to the underserved communities or underserved regions. And in that context, I think maybe if we look at a bit in terms of the water as a value chain, the demand and supply are the two core areas. But if we still actually bifurcate some more areas, you look at the source, storage, distribution, consumption and discharge. These are the 5 broader areas which I think we need to look at in terms of if we really want to find a sustainable solutions. The trust which actually has been, as Professor Greg mentioned, about around 5,000 villages in 12 states. The idea is actually how we can create innovative models and look at a more successful innovations which can be then replicated on a large scale. So the idea is actually not to work only on in a silos, but create a model and try and see that how it can be mainstream with the government or other like-minded institutions who are in this space. As we know that, and there are 2 areas which I would focus more in terms of water quality, and second is about the water conservation. If you see the water conservation aspect, if we look at the storage infrastructure, so there are some striking, I think, facts there. If we look at the per capita storage capacity in India, which is around 190 cubic meter, whereas if you look at the Australia, Greg actually comes from there, and it's actually having a 3,245 cubic meter storage capacity per capita. I think if you see the huge gap in terms of the per capita storage capacity. Interestingly, in India, I think we are actually in a position to only 8% annual rainfall which is being captured for a storage, and only 5 states in India contributes around 60% of the total reservoirs. So I think the disparity in terms of the potential of water conservation, and I think the actual ground level storage happening is huge, and how we can address those things. And hence I think we worked on in India in terms of looking at the more diverse geographies. We can't have a single solution in India because you look at the semi-arid region, you look at the floodplain areas, you look at the hilly regions. We need to look at a more context-specific solutions rather than get a one single solution fit to all problems. So what we try to do that in that context. So we see that how we work at more on a decentralized models of a localized solution. When the first speaker spoke about the managers of water, I think what we believe, and I think we have been promoting, that the users of waters are the best managers of water. Unless and until we actually have a local communities who are actually involved into the planning, design and execution, the system will not be sustainable. So I think how we look at more in terms of the community engagement, use the traditional knowledge and understanding, and I think bring some kind of a scientific understanding and match that 2 things to find a solutions rather than start in giving prescription. I think that's the very important learnings for us to over a period of time. Second, I think aspects what we focus is on about every village should actually become a self-reliant about their water needs. And when I say water needs, water could be for drinking purpose, for agriculture purpose, or any other domestic use purpose. So I think the understanding of communities about what is their water availability, both on a groundwater and surface water, what is the potential to enhance those capabilities, and at the same time what is the demand, and how they can actually match that water availability and demand part, and they have to actually ensure that they should plan their water use and make a water positive footprint. If we actually ensure that this knowledge passed on to the communities, they would be better equipped to solve their own problems. And one of my mentors always say that when we find a solution to a problem, our question gets changed. So it's not something which we found that, okay, we got a problem answers for this problem, but I think down the line 2 years or 3 years or 5 years, our new questions will come. So rather than finding the static solutions, how we can actually creating the capabilities to ensure that how they can ensure the resilience of the community so that they can find their own answer rather than rely on the external sources. Second point, which is most important, which we actually focus on the Himalayan region, specifically looking at the spring shade management program. So we work in Uttarakhand, Nagaland, Mizoram, Arunachal, we try to focus that how, because 90% of sources in this Himalayan region and hilly regions are dependent on the springs, and it has been drying up very, very fast. We're trying to look at how we actually understand the geohydrology, scientific approach, looking at the data, and then provide all those information to the local community so that they can decide their solutions in a longer term. And that's, I think, important about the both conservation and usage part. The second component which I was asked to share about learnings about the water quality aspect. I think we know that there are data on arsenic, fluoride, nitrates, salinity in India, but if you don't find any data on the microbiological contamination, because it's more dynamic in process, and that's, I think, one of the most core reason for actually diarrheal disease burden in India. So we try to look at how we can actually address the chemical contamination issues as well as the microbial contaminant issues, and it should be more on again going from the community level to the household level. So one thing is about changing the behavior of people, that they need to understand that their water before they drink needs to be safe. So we can't rely on because our efficiency level has not been great, so that we can't rely on the people who are doing the purification will be of the required standards or not. So we actually partner with the organization University of New South Wales, Tel Aviv University, IITs, MIT, trying to see that key global technologies need to be adapted to Indian conditions. So it's important that someone has to take that risk in investing into research. Being a philanthropic institution, we try to see that how we can invest into the research so that we bring the innovative technology and actually make it contextual to Indian conditions. Otherwise, I think the very good technology may be good for the maybe Western countries or Europe, but may not be applicable to Indian context because of the local conditionalities of the availability of energy, the supply chain mechanism. So trying to see that how this contextualize is important. And again, the first is the local solutions should be made at the local level so that the supply chain availability can be ensured very effectively. The second part, and I think we have done some work on the arsenic, fluoride, and now also we are starting some work on the microbiological contamination and creating some kind of a social entrepreneurship model that it should not again dependent on the external source, and then the local people can provide the solutions as and when they require. So I think what we learn over a period of time in terms of important that we need to find a community as a core process holder for any kind of a solution. And in these 12 states, we developed some island of success, and in few states we could actually really put these solutions with the government. So government adopted those solutions and then scaled it up. We also work with the Ministry of Jal Jeevan Mission, try to see that how we can actually see that these diverse solutions could be infused into the ecosystem, and at the same time creating a platform where I think the academics, research professionals, civil society organization and government come together. I think someone has to provide that kind of space where everyone can come together and work towards a common direction. So that has been our experience in the work, and I think this is a good platform where I think we feel that the more and more innovations would be required, and I think the institutions and academic research have to be part of the mainstream program looking at the problem statement. And when Professor Leslie first came in India, I think in 2016, actually we took them, you need to identify the problem on the ground. So he spent almost 10 days in the ground talking to communities, understanding the issues, and then say, okay, now how we can put this context into the research perspective and come out with the very innovative solutions. So that's the approach we feel is more sustainable, and I would like to thank Professor Greg and the GRIHA for providing this opportunity to share our learnings. Thank you very much.
And finally, we have Dr. Sherly, who's an assistant professor in regional water studies here at TERI School of Advanced Studies. Cheryl has a master's degree in hydraulics and water resource engineering from IIT Madras and a bachelor's degree in agricultural engineering from Kerala Agricultural University. Cheryl completed her PhD through the IIT Mumbai Monash University, which is another university in Australia, joint PhD program. And so she's a hydrologist who specialises in floods, which is the other side of the water problem to water scarcity, that we get more rain in shorter periods of time than we have been in the past. And so Cheryl's going to present two case studies today for us, one on Delhi and one on Mumbai. And would you join me in welcoming Cheryl?
Is there any point? Yeah, sure. Yeah. So, good morning, everyone, and thank you, Leslie, for a nice introduction. Here, I'll be giving a glimpse of water stress of two cities in India. As far as India is concerned, both Mumbai and Delhi are very important, because Delhi being the capital city of India and Mumbai being the commercial capital of India. So, I am not going for a very detailed kind of discussion. I will just brief it within 10 minutes. Here, I will be talking about climatic and demographic features between Mumbai and Delhi and how the contradiction works. Then urban water demand versus supply, few facts and figures, status of sewage treatment of both the cities, and conclusions. So, at a global scale, with respect to the population, Delhi and Mumbai rank 2nd and 5th amongst the most populated urban agglomerations as in 2014. And there are lot of research studies on various meteorological parameters, and with respect to temperature, wherein we can say if the temperature of a particular day is more than 35 degrees Celsius, we can conclude it as a hot day. So, this particular study, which was done by Padmanabhan et al. In 2019, which was published in one newspaper in which is Live Mint, I found it very interesting in terms of the number of days which is increasing. During 1959 to 68, there were 1350 hot days, whereas by the time it's shifted to 2009 to 18, we can see 1465 hotter days. Similarly, for Mumbai, it is 113 and 313. So, what it indicates with respect to water stress? We can say that water demand it can actually lead to increase in water demand and reduction in water supply. And here, coming to the average annual rainfall of India, we know the location of Delhi, wherein the average annual rainfall is around 700 millimeter, whereas in Mumbai, which is a coastal megacity, and we receive, the city receives on an average around 2400 millimeter of rainfall. So, essentially we can categorize Delhi to be semi-arid, whereas Mumbai is humid region. And there are other attributes with respect to water supply and demand for both the cities. Geographical area, if you see, Delhi has more than 3 times of Mumbai. With respect to administrative boundary, I will say Delhi as National Capital Territory, whereas for Mumbai I am just referring to MCGM, which is Municipal Corporation of Greater Mumbai. And The anomaly which we can see here is the population density, 11.3 which is 11,300 on an average is the population density of Delhi, whereas for Mumbai it is 28,300 persons per square kilometer. So essentially Mumbai is the second most densely populated city in the world after Manila, and slum population were in the least privileged section of categories of the society is there. 49% of Delhi's population is lives in slum or in some other unauthorized colonies, whereas 42% of population in Mumbai lives in slums. Coming to the water scenario in Delhi, I'll just go through the text on the left hand side. Similar to what Dr. Syamal Sarkar discussed, average level of exploitation of groundwater in Delhi is 137%, which says that with respect to the recharge which is happening for the groundwater, 137% extra of draft is happening. And the projected demand by 2021 is around 1174 mega gallons per day, and water availability in the premise of households. With respect to two different categories of the society, we can say planned colonies, it is 78%, whereas for slums it is just 51%. And this is one news which I found it very interesting for on the right hand side, that is Capital's water woes, which came in the newspaper on March 25, 2018, which is a summer period, I should say, and they have mentioned the availability, overall capacity of Delhi's water treatment plant as 906, and they have clearly mentioned 70 mega gallons per day is a shortfall in water supply. And they have talked about different water treatment plants, which I am not going into the detail, but here one interesting aspect which I found is the relative proportion of water allocation to Delhi through different means. One is Yamuna River, which is contributing around 41%, Ganga 26.3, Bakra storage 23.9, and groundwater and tube wells, which is 8.8%. So, if we look at the administrative boundary wise, Delhi is totally dependent on its water source from neighboring states that can lead to water conflict if the upstream of these catchments lead to further urbanization, which will require more water supply for those areas. And here, when we talk about water supply, sewage treatment is also an important aspect. So here, if we say, if we see here, this particular article came in 2014, and it is about the new project which is coming up in Delhi, and we can see the map wherein the blue area, which is the sewerage area, and red is sewerless area, and green is definitely green area. That is how it has been shown. So you can see the extent of sewerless area in Delhi, which calls for the pollution which it causes to the nearby water body, and mostly it is Yamuna River. Yeah, and it is very clear that 50% of Delhi is unsewered. And here I am not going to explain much, but I just wanted to tell you that at the center I have just shown, I mean, this is a dashboard for Delhi with regard to Composite Water Management Index published by Niti Aayog in 2019, and we can see that with respect to data availability for the different indicators, the capital city does not have data for the financial year 15-16 and 16-17. So, until and unless you can quantify, how are you going to manage the problems? And now I am coming to the Mumbai city aspects, and you know Mumbai is humid region, it receives heavy rainfall, and it is a severely flood prone city. On an average, annually it faces floods, and annual rain, on a day, if 100 millimeter of rainfall occurs and with a high tide, it is a recipe for disaster in Mumbai. And on the left hand side, I have shown the 7 lakes which supply water to Mumbai city. And interestingly, we can see out of that 6 lakes, here 5 lakes, just a minute, 4 lakes. Yeah, these are managed by Municipal Corporation of Greater Mumbai, which are outside the purview. Administrative boundary wise, it is outside, still managed by MCGM, and only one reservoir, Bhatsa, is managed by Water Source Department. And another interesting aspect which I found is, if you look at within MCGM area, which is deep blue, Tulsi and Vihar, those are the 2 lakes which can be called as sources of water supply within the city limits. And if you look at the circle which is on the right hand side, this is a news which was published in 2019, we can see that Tulsi and Vihar, it is contributing only 1 to 2% of city's water supply. And one advantage for Mumbai compared to Delhi is that all these lakes of Mumbai which contribute to Mumbai's water supply are within Maharashtra, which is a state of which is the state wherein Mumbai is located. So in a way it might lead to less conflict compared to Delhi situation. And here we can see the on left hand side, I have just shown the water basins like hydrologically the basins, river basins which are contributing to water to the city, and there are multiple basins which are nearby contributing to the city. And this clearly shows that the need for Mumbai to preserve these river basins in order to have continuous water supply. And on right hand side, it is a very interesting calculation which Times of India on July 3rd this year they have come up with. What they have done is just they took 2 days of Mumbai rainfall during southwest monsoon, that is July 1 and 2, and they have calculated the water which can be harvested, and they have compared it with football field, because we all are interested in football and cricket. So football field, and finally what conclusion they have come up with is around 7,922 football field sized swimming pools which are with 4 meter depth deep water can be created just with 2 days of rainfall in Mumbai. That means around 10% of Mumbai's area. So if rainwater harvesting is implemented properly in Mumbai, in a way Mumbai can contribute a great percentage of its own water demand. And here is the sewage treatment status for Mumbai. We can see on the left hand side the water sewage treatment plants, and it looks optimistic. Whereas on the right hand side, in the legend we can see STP capacity, treated and untreated, and the purple color which is untreated. It means that there is a long way to go for these cities in terms of sewage treatment, because finally in case of Mumbai, when all this untreated sewage is going into the rivers, so these rivers are completely polluted, and the main river which is there in Mumbai, Mithi river, it is considered as a drain by Municipal Corporation of Greater Mumbai, whereas the apex body which is MMRDA, Mumbai Metropolitan Road Development Authority, considers it as river. So that is the kind of contradiction which is there in the administrative setup that leads to these water bodies continuing in polluted state itself. So finally, let me go to the conclusions. As we all know, without sustainable water management, even high rainfall regions may also face water stress like Mumbai. And water supply and sewage treatment are two sides of the same coin. Until and unless you solve sewage treatment, you will not be able to have sustainable water supply as well. Approach to sustainable water management should be site specific, just like the previous speakers who were on the same page on that. Then with respect to Mumbai maintains its water sources within its own state Maharashtra. while the source for Delhi is from its neighboring states, leading to water conflicts. And last but not the least, proper water management in cities can mitigate both floods and droughts. Thank you.
Okay, and sorry, finally we will hear from Mr. Amar Tendulkar, who's the head of design of Mahindra Lifespace developers. And Amar has a lot of experience in both design and sustainability. He's overseen the design, identification and implementation across Mahindra's Lifespace developments, which encompasses residential projects, integrated business systems and industrial clusters. He has more than 24 years experience in architecture and real estate development. So would you join me in welcoming Amar?
Hey, good morning everyone. Amazing presentations by everyone. I am the last and I am fortunate to listen to all of you. So what I thought is, I also have got a lot of data and research which has been, published by various institutes. And but I thought that, after listening to all of you, if I can be more spontaneous and probably I can add some thoughts, which have come to my mind after listening to all of you. So some data points I'll just put which I feel important. I'll talk about what is the real estate developer's role, particularly in terms of the water conservation, how we can contribute towards saving the water. Because the real estate development, the housing, it's like blood in the body. So we have got 90% of the blood in the body and this 10% is the bone. So what we are going to contribute in terms of the water conservation, it's for the 90% of the what development that we do. So I just want to start with a very light note. पानी क्या है? कहता है हमारे दादाजी ने तो उसे नदी में देखा था. Our grandparents have seen it into the rivers. पिताजी ने कुएं में देखा था, तो fathers have seen it in the wells. हमने जिसे नल में देखा था, we have seen it in the taps. और हमारे बच्चों ने, और probably हमारी generation bottles में देख रही, we are seeing it in the bottles. So where the next generation will see? Do we want to see them in the capsules? So this is a kind of a thing that where we are heading to today in terms of the scenario of the water. So just I am telling you, after I heard from Israel and from Australia and then India, Delhi and Mumbai cities, I just want to draw attention to the point that how we are different, in the Indian context or the urban Indian scenario than the world. A quick points in terms of the population metrics. New York has got about 2,050 persons staying per square kilometer. Tokyo, which they say it's the most populous city, 4,750 human beings, people staying per square kilometer. London has about 5,100. Paris, it's a bit little on the higher side. It's about 20,000. Macau is again on 20,000. Where Mumbai stands, Beijing is again at 11,500. And now wherever Mumbai and cities like Mumbai and Kolkata are. Mumbai, this data is about 4 years old. So Mumbai at that point, it was about 30,000 people per square kilometer. So, so see the comparison, and Kolkata is about 24,000 persons per square kilometer. Delhi, because of its NCR reasons and the green circle around, it's still little lower at about 12,000 people per square kilometer. But if you'll see the heart of the Delhi or more populous areas of the Delhi, Gurgaon, Noida, it goes about 16,000 people per square kilometers. So what it all shows, we have got our unique problems in terms of catering the population. Some of the data shows that the freshwater withdrawals are expected to rise by 2025 by about 50% in the developing countries and by 18% in the developed countries. So 50% in the developing countries and 18% in the developed. So where this 50% is going to come from? That's the question that we need to ask. And I'll just show something. The volume of water used by the industries manufacturing industries is estimated to rise significantly from 750 kilometer cubes per year, kilometer cubes, imagine, from 1995 to about 1200 kilometers cube by, it's about almost about 25%, which is the UNESCO water assessment. So this all water, so in the developing countries, the withdrawal of water is going to be more than the developed countries. So as the developing countries, the stress on us, or the onus on us in terms of using this water more carefully is much more. So what it results into? It will result into the declining in the potable water. Okay, it will, ultimately, as you rightly said, the most reliable resource of the water is the groundwater. So it's a, lowering down the groundwater level, and the deterioration in the quality, it will generate into the groundwater contamination. Once the contamination starts happening, it will generate into the, the epidemics and the waterborne diseases like hepatitis, typhoid, diarrheas and all. So we need to be more careful, our next generation is to be more careful about that. So these are the things I think as a developing country we need to be mindful of in doing few things. Now in the developing countries, yesterday I heard our Minister Gadkari also, and the efforts which have taken in the Yamuna and Ganga Namami Gange, which is our central government's one of the most important projects in terms of determining how the water can be purified water can be used across the urban areas in India. There are some water, I can say this is more spontaneous, there is some water, it's like the river linking and drawing the canals from the major rivers to the deserted areas of India. Those have started getting into the, into the geographical parts of various parts of the India. Some of those are like the Jawar canal, which is from the river, the canal which is drawn from Narmada to Sabarmati. And there is another effort which is going, to draw the water from the north side, from the Ganges towards and getting towards the western part towards the Jaisalmer. So there are some studies which have started showing, yes, instantaneously these are the things which are providing the water. Ahmedabad, I remember in 90s when I was studying in the Ahmedabad, we did not have the water even after the, we used to go and run towards the Sabarmati river, ki arey pani aaya, pani dekhne ke liye chalte. And now there is a 24 hours water. But now after 15 years, 20 years, some of the studies in the UNESCO have started showing Ahmedabad has got a lot of heritage areas. Okay, and in those yesteryears, the foundations were built with the yellow stones or the sandstones. And now they have found those foundations are the water soluble foundations. Now the uprise in this groundwater level has started kind of dissolving those foundations. And the similar problem they have started, this problem was first kind of found out in Jaisalmer. So the similar problem was seen even in the Jaisalmer. So my point is, what we are saying is, when we are doing all these efforts, that we have to be mindful about the efforts, in which directions we are going to do the efforts. We have to be going along with the nature. We can't be forcing something onto the nature. If we have to take this way, in terms of the otherwise we have seen in the past years that the waters have changed its direction, sources have changed its directions, and we have got the histories like Mohenjo-daro and Harappa, and many believe that those have kind of all washed off because of the Saraswati's water channel which is changed about few thousand, 5,000 years back. And Dwarka again, in our Vedic times, it has gone below the water. So some of them, they believe this is the change in the water sources direction. Some of them, they believe it is because of the climatic change. But yes, there are examples which show when we enforce something on the nature, how it reacts. We have got the recent examples of tsunami also, which have happened. And these are all the examples of the climatic change or the global warming. Having said that, now I want to say as the mindful developer that what we are doing in terms of the scenarios, we have got the cities, mega cities which are coming up. We have got in Chennai, Mahindra World City. We have got in Jaipur, our Mahindra World City. One is 3,000 acres, other is 1,500 acres. Now all these developments cannot happen without having the cohesive kind of an approach. So cohesive in terms of the community, cohesive in terms of putting the resources in the right direction, cohesive in terms of treating the water mindfully and carefully. So we have got Kulawai Lake, which is in Chennai. The lake was almost kind of a no water kind of a situation, dry kind of a situation. So Mahindra has taken efforts, and I can say that we have rejuvenated that lake in that while we are bringing that entire 3,000 acres of the development. We are still little away from making that water use for the potable purposes, but I can tell you very definitely that it has changed the microclimate of that area, and the region which had kind of a very kind of, I can say that very deterrent in terms of the growth of the trees, in terms of the arid climate. Now that climatic conditions have become more livable, we can grow more amount of the trees. The area has become more green in that region. And in the recent past, when the entire Chennai was flooded, Mahindra World City, 3,000 acres of the Mahindra World City and the surrounding villages, those they come along with this development, were not as much flooded or still were kind of dry as compared and livable in those. So these are the kind of efforts when we take in terms of working with the environment, that how we can protect the environment. Similarly in Jaipur, we have got a water stream over there, so we are putting up a weir. We are saying that how we can reuse that water which is just going flooded and get vanished into the away from the city without any use to the people or the residents, those they are there. Of course, I mean, in our residential projects and in our other township projects, our efforts are to almost about 90-95% of the water recycling, which we use for the, the STP water, which we use for the flushing purposes, for the irrigation, the landscape irrigation purposes, and mainly not all other uses, but which are not potable use. So this is what I can say as the responsible developer. So just a short note. What I said, it's what we can do. There is a saying that the human being thousands of the human beings have lived without love, but there is not an example of the single who has lived without water. Thank you.
Well, could you join me in thanking all our speakers? That was wonderful. And we have time for a few questions. So if you'd like to find a mic. Yes, sir.
Firstly, am I audible? Yeah. Firstly, I must thank all of you. This is a very important topic. Water is a very important topic. And Mr. Tendulkar, in fact, took my question off me as it is, because when I was listening to Sherly's lecture, this river linking project, and I would like to ask the water experts in this, the river linking project is considered to be a social and an environmental disaster. That's what most of the environmental groups put it up as, because when you, as he very rightly said, when you interfere with the ecosystem, you lead to a lot of problems. And as he has mentioned a couple of examples also, I have done a little bit of reading. There have been, the Institute of Rural Management, Anand, had also conducted a seminar on this. There is a book on this entire speech, and a lot of people have spoken against river water linking. There are a lot of environmental, social, and the cost is about approximately, I was reading up on it just now, it's about 560,000 crores. So what do the experts on water, since we have so many of them, and Mr. Sarkar has been with the government earlier, this proposal was mooted by Dr. Kalam, if I'm not very mistaken, a long time back. So I would like to know your take on it, because I have, the amount of reading that I have done on it, I think it's going to be an ecological disaster. It's something like, so I would like to know the experts' view on this. And what are we doing about it if we feel that it's not a very ambitious, it's a very ambitious project without any results? Thank you.
Excellent. Dr. Kumar or Cheryl, would you like to?
I think this is a subject which can be disputed at any length of time, because there are authorities who can speak on both sides. River linking projects is an initiative of the central government for many years. Since 1980s it has been going on, but in effect, in reality, the Ken Betwa is the latest initiative which is off and on being talked about in the media. You see, the river water, approximately 40% of the river water goes to the sea, approximately. Now, because the river water flows and it goes to the sea, so the proponents of this interlinking river, they are of the view that this excess water, you should tackle it, you should bring it to your use, Yeah.
Fundamental problem with that, sir. Water you are treating as a resource. Water you are treating as a resource, it's actually an ecological system. Please understand that. That is the fundamental problem. We can argue about it, but the water you are treating as a waste, that's precisely the problem with this. You are treating it, whereas the water is, the river is an absolute living ecosystem. That's the fundamental issue. That's what I feel is the.
Yes, in fact, there are experts who disputes this fact that this is not excess water. They feel that this water which is flowing to the sea there is use of those water by the ecosystem, So there is also a dispute. You see, at any length of point you argue on this subject, you will find another argument. Anyway, I am not going into that. What I am trying to say is that this is an issue which the central government has taken initiative for a long time, and this Ken Betwa is not the only one which is at hand. There are many others like Daman Ganga, Panjal, there are so many. But Ken Betwa is the one which is at very mature stage. After a lot of effort, so many clearances have been taken, but actual working is yet to take place on this subject.
Also, we have a pretty typical political problem which she mentioned. We have a political problem in this case. Even in Delhi, we have faced this problem because Haryana starts blocking the water the moment there is a dispute. So what do you have with so many states? You have the case of Tamil Nadu and Kerala having a fight about water. So when you have an interlinking across political boundaries, you're bound to face problems. That's why I would say that. I think that was my...
Excellent points. I think what we might do is
because this MP and the UP is the concerned states in this Ken Betwa, and in fact there is a lot of issues which are pending with the states. Still they are not agreeing to come to a single point of their deliberation. So you are absolutely correct that whenever there is a linking of river or any river sharing across a state, there are issues. In fact, even within the same state, the river, the water sharing is also an issue, because there are sectors there, your agriculture sector is there, industrial sector is there, your domestic sector is there. You will find a different, people are talking differently, maintaining their demand. That is because we have a shortage of water actually.
Yeah.
We are facing the water problem in reality, and the demands are growing up because of many reasons, and unless we take some steps, water management side, demand side, it will be very difficult for us to manage water problem. But this is an issue.
Yep.
Interlinking of river is an issue which has been going on for many years. It is not today, but many years, and it will keep on continuing unless we take some resolving steps for that?
Thank you, Dr. Kumar. In the interest of time, we'll just take one more question.
Yeah, my question is to Mr. Dan Alluf. It's heartening to know about the Indo-Israel cooperation on the agricultural sector. Are there any initiatives or projects that are planned on addressing the non-revenue water in the drinking water sector? Because that seems to be one of the burning issues in India, especially in the mega cities and most of the areas where water is considered as a very precious commodity.
Of course. So I would say NRW, non-revenue water, we are looking into cooperating or demonstrating in large-scale solution. We got a request both from Varanasi and Lucknow in UP. It is being discussed. It is not taken forward at this stage. But I think, again, it's always about water. It doesn't start and end in any place. It is a circle, and we must approach water challenge as such, meaning urban water, rural water, industry, agriculture, and drinking water should all work together, and Jal Shakti is a very important step towards this approach. So we are working. As I told you, it's a short answer to your question. We are working towards this. Companies from the Israeli private sector are active in India to implement solutions such as metering even. When you meter, you measure. When you measure, you can manage. So this is being done. And it's always about the local leadership, taking forward these solutions that are in the toolbox and just making them into an applicable one.
On that note, I would like to thank our esteemed panelists for such an engaging session. Considering that we're running slightly late, I would first like to announce the thematic tracks that are going on parallelly. We have several thematic tracks that are parallelly happening in the different halls. We have in Silver Oak Hall, we have thematic track 7, social aspects of sustainability. In Jacaranda Hall, we have thematic track 8, sustainability for schools, dreams or reality. In Amrita's Hall, we have thematic track 9, sustainability in the clothing industry. I would like Professor Greg to kindly present a memento to our esteemed speakers. We can Dr. Syamal Kumar Sarkar. Dr. Sherly. Mr. Dan Alluf. Mr. Divyang Waghela. And finally, Mr. Amar Tendulkar. Thank you, Professor. May I now request Ms. Shabnam Bassi, Secretary, Griha Council, to please present a small token of appreciation to our esteemed moderator, Professor Greg Leslie. Thank you, ma'am. Additionally, I would like to bring to your attention the coffee table on the dais, which has a unique surface made from new panel products currently being developed in the UNSW microfactories. The panels are based on technology developed at the Smart Center UNSW to upcycle problematic waste, glass and textile. With this, we would like to close the session. Tea and coffee is being served in the hub area. Thank you so much, everyone. I would request everyone to please proceed to the thematic tracks that have already started in the various venues. You may connect with us through social media by following us on Facebook, Instagram, LinkedIn and Twitter page. Please use hashtag Griha for all and hashtag 11GS while tweeting. Thank you.